Good morning. My name is Vishnuvardhan. I am from Electrical and Electronics Department. And today my EC concept video topic is supernode analysis problems. Let's see what is node analysis. Node analysis is just used for solving an electrical network, and it is defined as the mathematical method for calculating the voltage distribution between the circuit nodes. This method is also known as the node voltage method since the node voltages are with respect to the ground. The following are the three laws that define the equation related to voltage that is measured between each circuit node. Ohm's law, Kirchhoff voltage law, and Kirchhoff current law. It is related to Kirchhoff current law, which states that the total or algebraic sum of currents meeting at a junction or node is zero. Every junction where two or more branches meet is a node. One of the nodes in the network is taken as reference node. If there are n nodes in a network, the number of sim- simultaneous equations to be solved will be n minus 1. The mathematical methods for calculating the voltage distribution between the circuit nodes. This method is also known as the node voltage method since the node voltages are with respect to the ground. Supernode analysis or supernodal analysis is still considered as the nodal or node analysis, but with a special case where a voltage source exists in an electric circuit. If we observe carefully or read the nodal analysis thoroughly, we avoid analyzing an electric circuit with a voltage source using nodal analysis. The simple nodal analysis can't solve an electric circuit with a voltage source. We need to modify the to a circuit to a bit before applying nodal analysis. The modifying circuit and solve it with the nodal analysis is called supernodal or supernode analysis. After learning this analysis method, we don't need to avoid using nodal analysis for a circuit with a voltage source anymore. So when we know that a when three or more are joining together, that is known as node. As we can see here, this is one node and this is another node because more than three branches are connecting together. So by this is known as node. Let's see what the question is. Observe the circuit in figure below and find the node voltage. Let's find the node voltage to it. It has one source of two voltages, and here are the two nodes V1 and V2 and resistance of 10 ohms, 2 ohms, 4 ohms, and these are the just as we read before. A supernode is formed when a voltage source is connected between two non-reference nodes and any elements connected in parallel with it. In our case, the supernode consists of two voltage source, node 1 and node 2, and the 10 resistors. We remove those to redraw the circuit below. We re- so here we can see we removed 10 ohms resistor and we redraw the circuit and the circuit look like this. Now let's apply KCL for the super. We will use KCL for the super node. We get 2 equal to I1 plus I2 because the voltage is 2 and the currents are I1 and I2 plus 7. Writing the KCL equation for I1 and I2 using node voltage variables gives 2 equal to V1 and minus 0 because it is ground by 2 plus V2 minus 0 by 4 because it is also connected to ground plus 7. 8 equal. So by doing LCM, we will get 28. So by doing that, we get 8 equal to 2v1 plus v2 plus 28. So v2 equal to minus 20 minus v1. We are still missing the relationship between v1 and v2. So we will use KVL to the circuit in the figure. From the clockwise loop, we get minus v1 minus 2 plus v2 equal to 0. So here minus v1 minus 2 plus v2 equal to 0. So here we apply clockwise loop. So by by using symbols we can write minus v1 minus v2 and plus v2 equal to 0 and v2 equal to v1 plus v2. From equation 1 and 2, this is the equation 1, v2 equal to minus 20 minus v1, and this is the second equation, v2 equal to v1 plus 20. v2 equal to v1 plus 2 equal to minus 20 minus 2v1. So by simplifying this equation, we get 3v1 equal to minus 22, where v1 equal to minus 7.333 volts. So we should substitute v1 value in any of these two equations. We get v2 as minus 5.333 volts. So by using super node, we can solve, we can calculate the voltages across any branch or anything using super node easily. So first we have to identify what the node is, where the nodes are. Here is 1 and 2, and let's make this as ground. By doing this, the circuit look like this, where V1 and V2 are the two nodes, super nodes, because three branches are connecting together. When three or more are connecting together, they are called as nodes. So this is how we calculate the supernode voltages by applying KCL and KVL. Thank you.